Hi, welcome to this talk. My name is Pieter Cailliau, and in this talk we'll talk about Writebehind and read-through with RedisGears. This is a co-host of the talk by myself and Meir, the creator of RedisGears. The agenda for today, we'll talk about why RedisGears, why we've built RedisGears, and when do we see a good fit. For which use cases do we effectively think RedisGears is the right tool within your toolbox. And then Meir will take over and talk about RedisGears 1 to 2, what is coming up, and also talk about how we solve or build recipes for Writebehind and read-through, and a short demo. By myself, my name is Pieter. I'm produced in Belgium. I used to be a software engineer at TomTom and also a former consultant at Neo4j. And right now I'm leading the developer capabilities product team at Redis Labs. And I do believe my dog is a unicorn. Now let's go over to why we built RedisGears. For that I'm going to tell 3 stories. These 3 stories effectively tell you something you can do with Redis, but not in an ideal way. Effectively, RedisGears will be solving each and one of those 3 problems. The first one is effectively capturing change within Redis. Your application is writing into Redis, and if with the current means, you can effectively do real key space notifications to do post-processing. The post-processing could, for example, do the Writebehind, could do the writing your updates of your changing those keys into another database. However, key space notifications are not reliable. It's a fire and forget. So once there's a problem, for example, with the connection between Redis and the post-processing, you will never receive the update or the writes within the database. There must be a better way for that. The second story is about what if you want to do, for example, an aggregation. What's the average of all the elements in a list that start with the prefix rating? If you would do that, one way to do that would be to, for example, to use your application to scan all data within Redis and to fetch all that data and then post-process it application side. Now we can see that all that data has to move outside Redis. That might not be the most optimal way. So Redis also supports Lua. And what we could do is effectively send the Lua into Redis to do the processing server side. Lua will, however, block the main thread of your database, which won't be ideal for operational purposes. And also there's another problem with that. Lua only works within a single shard. So what about clustered databases? The third story is about the efficiency of stream processing. Streams are more reliable than pub/subs notifications. So in this case, the application writes a message into a stream and there's a stream processing on the other hand. However, the stream processing also needs to fetch some other reference data to do an enhancement or an enriching that also resides in Redis. After that, it can write it back to a stream, or additionally, it could write it back into any of the other enhanced developer capabilities, such as time series, Graph, or Redis Search, or Blue. Now, all of this effectively is happening or is generating several round trips in between Redis and stream processing. That could effectively be done more efficiently. What if that stream processing could be done within Redis itself? And that is what RedisGears is for. RedisGears is a serverless engine for transaction, batch, and event-driven data processing in Redis. The batch processing can be, for example, a MapReduce, and the event-driven processing can be either updates or written into Redis, or it could be messages arriving into a stream in the stream data structure within Redis. It's a dynamic framework for the execution of functions, we call them functions, that in turn implement data flows within Redis. And very importantly is that it's also abstracting the data's distribution and choice of deployment. So once you've written a function against a standalone database, you can also run it in a clustered database. Currently, we have support for C and Python in RedisGears. We also have support for RedisGears within Redis Insight. So Redis Insight is the GUI for developers for helping them be more efficient with building applications with Redis and also with RedisGears. So in this case, we see a view of all the functions that are registered within RedisGears. We can also see which executions are available, how often that function effectively was triggered as an execution. And we can also write new functions. In this example, we're creating a new function written in Python and executing it within RedisGears. So when can you use it? Well, first of all, Redis is all about real-time, and we're building the fastest database, as Siftach pointed out in the keynote. So it's about fast data processing. You can effectively now run those functions with the data, right, within Redis. And other use cases could be to orchestrate AI transactions. AI, lots of people already use Redis as a feature store, but these features sometimes in a real-time fashion, they need to be generated from raw data with a certain feature pipeline to do your feature engineering. That can now be done with RedisGears within Redis. You can also do cross-data structures operations and also do reliable event processing. The combination, for example, might be able to allow you to receive a message within a stream, and you could want to apply that same message into your graph representation as well as into your full text search index. A last use case that we see coming up quite often is Writebehind. Writebehind is a caching strategy. It's used oftenly to offload your primary database, to spread the writes to flattened peaks, for example, on a Black Friday, to batch multiple writes. Several updates that happen into your front-end database can be batched in one single write into your typically slower primary database, and effectively also in that way your application can experience a lower write latency. This is available as a recipe, and we also have a recipe for read-through, and Meir is going to talk to you more about that.
Thanks, Pieter, and hi everyone. My name is Meir, and I'm a software architect at Redis Labs and the creator of RedisGears. And today I'm going to talk about RedisGears and some new feature that was recently added. Before we will start, I would recommend everyone to look at our first presentation from last year that give you a short and a nice introduction to RedisGears and what you can do with it. In this talk, we are going to cover some more complicated stuff. So let's get started. So we are going to talk about RedisGears 1.2 and what we can expect to have in RedisGears 1.2. We are going to talk about the JVM support. We are going to talk about Writebehind and read-through, which we implemented using the JVM. And we are going to show a demo of Writebehind and read-through. We're also going to show a short demos in between, so we will allow you to understand better the new feature that RedisGears give you. So RedisGears 1.2. So the most significant thing we changed on RedisGears 1.2 is the plugin mechanism. Instead of Python as built-in inside RedisGears, now the Python interpreter is a plugin, so you can choose if you want to use it, or you can choose not to use it. In addition, you can choose to use the JVM and not the Python. So you can basically combine the languages that you want to use and only plug into RedisGears the languages that you want to use in order to create your gears function. Another feature that we added is async await support. This feature allows you to use coroutines in Python inside your RedisGears function. And another feature is override commands and replies. I want to show you the first feature first, which is async await support. And I want to explain why you need it. So let's look, for example, on this simple RedisGears function. This simple RedisGears function is simply register on a command reader with the command delay, and it basically delays the client for 10 seconds. Now, I know it's simple, and I don't know if someone will use such a command, right, to delay the client, but you can think about it as, for example, we are going to external database. We are doing some operation that might take time. So this is the example, and I will run it. And I have here already RedisGears running, and you can see that the Python is now a plugin. It's not built in. So RedisGears loaded the Python in a plugin. And another thing that I want you to see is that I already set the execution threads of RedisGears to 1, which means that RedisGears only use one thread in order to run the functions. Now, let's see how it works. So I already uploaded my function into RedisGears using the PyExecute command. And now I'm running it using trigger and the name of the trigger, which is delay, as we did it here. So if I run it, you can see that the client is delayed for 10 seconds. Now the problem with this approach is that we only have one execution thread. So while the client here is delayed, I cannot run any other RedisGears executions. All other execution will be delayed as well, up until my delayed client is finished. So how can we change it, and how can we use async await to avoid this? Right? We want to allow other execution to run while one execution is waiting for something. So what we can do here, for example, is instead of using time.sleep, we can use async io.sleep, and we can await on this. And also we need to define our function to be a coroutine. Sorry. Like this. Now, if we will register this, and let's just restart our server to register it. So now we register it, and we can see that we still get the same effect of delay client, but we can run our execute. Now there is no keys, but if I will set some keys, sorry, you can see that I can still run it even though I have a delayed client. So this is the idea of async await, and you can think of it, for example, in our use case where we needed to do a read through. We don't want to block all the other client while we're reading for external database, so we can use those techniques to do the long operation of reading for external database in the background and not blocks all the other clients. So this is the first new feature of RedisGears. The second one is override command and reply, and this is an important feature because now you can basically not just register on key space notification, but you can also override the replies in case that your key space notification was actually triggered. And I want to show you this simple example, so let's go over it. I will copy it here. Here, we don't need the async IO. In this example, what I'm doing is I'm using the keys reader, but I have a new argument which calls commands that basically tells the keys reader I want to fire the event on commands which is ageGet, and I want to fire the event only on key miss. So in this combination, we will get the ageGet event each time the ageGet is missing hitting the key. The key that it tries to fetch is not exist. And in this case, we will return a key miss reply because we are overriding the reply. So let's see how it works. I will just restart it again, and let's send our execution. And now, if we will try to fetch a key that does not exist using ageGet, you will see that we are getting the key miss, which is the reply we ask to override. So why is it good? Because we can register on ageGet and ageGetAlls, for example, with the event of key miss, and we can, in this case, using async await, go and fetch the key from the backend database and override the reply and return the reply as if the key was exist in Redis. So this allows us to perform the read through. Now let's talk about the JVM plugin. So in RedisGears 1.2, we said before we have plugins. Python is one plugin, but we also implemented the JVM plugin that allows to run JVM languages and write your function in JVM languages. So here, for example, we have a simple example. that shows you how you can create a keys reader. The API is very similar to the Python, but with some modification that will be more compatible with Java. So you create a keys reader, and in this keys reader we fire each time a key is changing. But we don't want to fire on expired events, so we filter them out, and those events that was not filtered was probably writing to a key. So in this case, we are setting a default expiration of 1 second, and we register this execution. So what this execution will do basically is give us a default expiration on each key that we will write to Redis. And I will show you now. So I'm starting another Redis server with RedisGears and with the JVM plugin installed. And you can see immediately that RedisGears recognized that we wanted the JVM plugin, and it loaded it, and now we can use Java inside RedisGears. So I have a small script here that will upload my code, the same code that I just showed you, and I will show it again. And let's run it. So basically what my compile and upload does, it's creating a jar file and send this jar file to RedisGears. So it was sent successfully, and RedisGears reply with an OK. And now basically let's connect to Redis and let's try to set some key. Let's try to fetch this key then, and we can see the key does not exist because the key was expired. If we do it fast, we can see that it's there for 1 second, and then at the second it's not there anymore. So this is a simple example that how you can use the JVM. We have a full API of the JVM, the same as with the Python, and you can use it the same way as with the Python. Now let's talk about Writebehind and how we talked about Writebehind last year, and we showed you how we implemented it with Python, but this time we implemented it using the JVM, and we leverage the Hibernate, so we can connect to more databases, and it will be easier for us to map in the data from Redis to the second database. But I will just go over it and remind to those who don't remember or didn't saw the previous year talk. I will remind you how it works. So the user is writing to a Redis database. Each such write to the Redis database is trigger an event that RedisGears is registered on such event, and RedisGears makes sure that the write is also written to a queue, which is in our case a stream. Now in the background there is another RedisGears function that reads from the stream and writes to the database, to the backend database. Why we split it to two parts? Because the first part should be very, very fast with a very, very low latency. The second path might be slow because we are writing to another database that might be slower than Redis. So we don't want to slow down the user application. We want the user application to be able to write to Redis very, very fast, and we asynchronously in the background will replicate this data to the backend database. So this is how it works. And as I said before, we re-implemented it using the JVM, and we are leveraging the Hibernate capabilities in order to be able to connect to many different databases and do a better mappings between hashes and the backend data. So here is an example of how you can upload the recipe that we wrote. It's called RG Hibernate. And you just send it using the JExecute command. JExecute command is a Java version of PyExecute. So you can send the jar file into RedisGears, and RedisGears will run it. After it was sent, this jar file exposes triggers that allows you to control and to configure the connections to the other database, and the mappings between the hashes and the tables in the other database. So here is an example of register a connector using the sync.register connector. It needs to get the connector name, the batch size, the timeout, and the failure retry. I'm not going to get into those details, but it's all documented, so you can read about them. And we need to send the Hibernate configuration of the connector, how we can connect to the backend database, the IP address, the password, credentials, and all those stuff. Then we need to register a source. A source is basically a mapping, how to map the hash into tables inside the other database. So we give it a source name, a connector name. We give the policy. We want here Writebehind. We can also do read through, as we will see in a minute. And then we give the configuration, the Hibernate configuration of the mapping. What fields you have, what type of fields you have, and all those all this information. Redis will automatically send each hash to the backend database and will write it to the backend database. Before I will show you the demo, let's go over the read through, which is totally new. It's something that we didn't have before, and we implemented it now with the JVM. So we have a user. The user wants to read the data from Redis. If the data is there, everything is good and the data is returned to the user. But if the data is not there, RedisGears uses the same techniques that I showed you before with async await and override reply. And it sends, it blocks the user, it blocks the client, it sends a request to the other database and gets back the reply. Once the data is returning to Redis, Redis is writing it locally to a key and also return the user the result. So the user is not even aware if the data was fetched from Redis or was fetched from the backend database. The only difference is the latency, because if the data is missing, the latency will be higher. And I will show it in a demo in a minute. So this is an example of how you can do it. Again, we are leveraging the Hibernate to be more compatible with different databases. And all you need to do is use the RG trigger, register source, source name, connector name, and you need to specify that you want a read through policy. You can also specify an expire. If you want your data to expire after some time, you can do it. If not, you can set 0 and the data will not be expired. So now let's see a demo. So here's my register command. I'm registering a connector called MySQL connector. Those parameters I said that I will not get into, but you can read about them. And I'm given the MySQL Hibernate configuration to contain credentials and the host and port of how to connect to the database. So I'm registered this one and I'm getting an OK reply, which is very nice. And now I'm register my source. I'm register a read source, read student, and I want to use my SQL connector and I want to do a read through. I want to read from those students. I want to read from this database the students. So let's register it and we get an OK. And I'm gonna do another one, last one, which is write student. I want my student not just to be read from the backend database, but also if they are changed, I want to be able to write them to the backend database, all the changes. So I'm going to register this one also. And I'm finished. I got all my registrations ready. So now let's look at what I have. Nice. So what can I first look at? So the first thing I can look at is the information about what registrations and what mappings I have. So I can do sync.info connectors, and I can see my single and only connector, which is a MySQL connector with information about it. I can also see my sources. Sources are the mappings. So I see that I have two sources. One source is with read-through policy and the other is with write-behind policy, which means that all the data with the prefix student here and here, which is written to Redis, will be written to the backend. But not only that, all the data with the prefix student, which are read from Redis and not exist, will be fetched from the backend database. So let's see it. I'm doing an 8set command on a student 1, and now I need to give the fields. So let's do first name foo, last name bar, email, and age of 10. So this data was written to Redis, and let's see if it was also written to our backend database. So I will connect to it. Nice, it's there. So now to show you the read through, I will flash my data. So I will have nothing on my database. And now I will read this student 1, which is not there, right? It's not in my Redis. So let's do age get all to student 1. You can see that was a slight delay, but I got the data. The data is there. And if I will do keys now, I can see that the student was written back to my database. So what I'm doing now is I'm writing with empty benchmark. I'm writing around 10K of request, which is basically 8 sets, and I'm using 10 clients, and I'm using some increasing key. So I think that the total it will write around 400K keys into Redis. So let's run it. Okay, so it's writing the data now. We need to remember that it's also replicating the data to the backend database. So we can see here that I think it's almost finished. Yeah, it's done. So if we will look at MySQL now, and we will see how much data we have there, we can see that we are still writing the data, by the way, and now we have 400K records, 400K student. We can also see in our database that if we will do DB size, we have 400K and another 4 key. Those 4 keys are basically the streams. They are not the data, they are the streams. We have 4 shards, each shard has its stream that we read the data from and replicate it to the other database. So those 4 extra key are the streams. Sorry. So now that we have the data in our backend, let's flush the data, and let's use memtir again to fetch the data. So you can see here that I'm doing age get all with the same generated key. So the data is fetched, and you can see that we are getting around 10K requests per second. Let's wait for it to finish. I will remind you that during the fetching, we basically adding the keys to Redis. So those keys are added to the Redis itself, and you can see that the amount of keys in Redis is decreasing. You can also see it here in the total keys. So it will finish in a second, and it's done. So now all the 400K keys are inside Redis. They were fetched from the other database. Our client was not aware of it. The only difference was that the latency was a little high, 3 milliseconds, 3.5. But if we will run now the same memtir again, you can see that it doesn't need to fetch any data from the backend database, and we are getting a much better performance and much better latency of 0.1 millisecond. So RedisGears 1.2 is coming soon. Stay tuned for more features and announcements. Continue follow us. Thank you very much for listening, and enjoy the rest of the conference.